Good morning. This is Dr. Roberts, and I wanted to begin our first video for the first chapter, and I will go through the 12 points. You see that there's 66 of these, and that gives you a little bit of hint of how much information is in this text. There's a lot of information. So I'm going to go fairly fast so that the video itself doesn't get really, really long. And we'll try to highlight the most important things in the chapter as we go. Do not figure on components not attacking. Worry about your own lack of preparation. So that's what this book is about. It's about the risk and analyzing those risks. Then once you do that is to analyze the tools that will take care of those risks. So one of the things that you'll see all through this book is how the IT personnel must have things in place that allow the users to be able to use the resources on a network easily, but still keep that network secure. And we all are involved with security. We have to have our own personal computer secure. We have spam fighters, pop-up blockers. Our internet service providers have firewalls. We may have even more firewalls of our own. So we have this on a personal basis, and we also have some kind of look at what it means in a business atmosphere. We can only imagine what it would be like, that scenario on page 1 of chapter 1. This lady named Amy worked at an IT help desk, and there's a company here in town called Parkus Rail, and they have hired a lot of our students, and they start them out on the IT help desk, because it's felt like if you can manage that help desk, you can manage about anything IT. But she is in a normal day's work, and then all of a sudden malware or a virus or something hits their network. And if you can imagine, I put one link that I absolutely love in this class, and if you've had me in other classes, you may have seen it before. This link from this site, and this is really a great site, they have the threats by the number of records that was hit. It also tells you that what the threat was. This one was a hacker, and what they did, what damage they did. Sometimes you will find that it's actually a online hookup site for extramarital affairs have been severely breached. Oh yeah, that was anonymous. The anonymous hacking group that got Allison Madison. But sometimes there are people that worked in the company. Whatever that actually was. So this is one of my favorite sites. Just take a look at it. All of our data is housed in all of these databases all over the world. All of us are records in a bunch of those databases. And so we have to think about our personal information, our credit cards, and using those. We also have to think about identity theft and all those kind of things. So there's and that's actually chapter 2. Let me not get ahead of ourselves, but the threats are there. We have to assess the risks and put safeguards in place to protect ourselves and our information. So this chapter, what is information security? And then there's history. There's history beginning in the 60s, and that's when computers and networks started, and that is also when security started. It evolved, security evolved as we evolved over those last years, 50 years or so. Key terms, critical concepts, the phases of security system development life cycle, and you see that all things, computer and engineering and different things have life cycles, and there's different stages in that life cycle as well. And so it's the same here with security systems. The information security roles in a professional organization, and it depends on the organization. One person may wear all those hats. It may be distributed over several people. There may be physical security that separate from information security. So lots of protection going on nowadays. So information security is a well-deformed sense of assurance that the risk, and that's chapter 6, and the controls are in balance. There's a little bit of a expanded definition in computer security that in our text that says in the early days it specified the needs to secure the physical location from outside threats, and then it's evolved to just preserve all security and network systems from loss, no matter what that loss come from. So we are evolving. Computers evolved over time. It's just the way it is. So you'll see all the way through this book that there's a balance between the ease of use for the users of the system and the resources on that system, and then the security that's required for that. So the history, the security began immediately after the first mainframes were developed. It shows us on the next one that there were groups during the war that tried to break into the first modems that were used. So breaking into code is not anything new. It's been there for a long time. The physical controls to limit access, and one of the chapters goes into the biometrics for entry. We're all unique in that our face and our hands and our fingernail, our finger thumbprints, our foot, all of those things are unique to us. And then nowadays with the internet, we have espionage and sabotage and cyber, criminals and all of those things. So our world truly become global with the invention of the internet and the allowing of the internet to private people, rather than just government and educational facilities that it started out as. A little bit of a timeline. So there were reports like the RAND report, the R609, that began being published with the first inventions of computers and networking. This is a test question. The two main reasons networks happened to begin with was they wanted to be able to share resources, whatever that resource was, a government document, a list in a database, whatever that resource was. And then they wanted to be able to communicate with each other over that network about those resources. And then a third objective, and it's a little bit different here on page 5 or there. That's page 5, the objectives. They wanted to network for sharing resources. They wanted to communicate. And then they wanted the security of the hardware in such that if one computer on that network went down, it didn't bring down the whole network. And if you have taken the first Intro to Networking class, CIS161, I believe, here at I think that's the number, is it 161? Then you know that there's a type of network that if one node, which is a computer or a printer or a router or whatever it is, attached to that network is called a node. If one node was down, then the whole line was down. You used to hear that a lot. Well, our computer's down, the network's down, and it was because if one went down, they all went down. So you don't see that as much anymore because networks are generally not configured that way anymore. So there's a timeline. The book gives us a timeline beginning in the 60s where ARPANET began. Then the 70s and 80s where the networks were being put into place. The first operating system called Multinex right there. It's obsolete now, but it's the first operating system created with security integrated into its core functions. Wasn't the first operating system. Was the first one was security. So didn't give us a date right there, but that was during the 70s. And um, then the 90s when normal, or not normal, but the average citizen began acquiring, the 80s and 90s when the average citizen began acquiring computers. And then around the 2000s when everybody started doing business online and buying online and using their intranets to do the business of the companies. So that's the first part of this chapter. We want to be able to secure the data, limit random and unauthorized access, and that's where it is a lot today. And then making sure a lot of people in the organization, everybody nowadays in the organization is concerned with security. So this talks about a little bit about the thefts and what might happen. I have some real horror stories about these things some of these that have happened over the years. I had a company call me one day to ask me if a certain student was in my class and wanted me to give them a message. And I said, well, if they show up to class, I'll give them the message. And she said, you tell him to unlock our keyboards at work right now. So the student worked for this company and he had remotely locked up all the keyboards in the company. I guess he got mad about something. I actually never saw him again or never talked to the company again, so I don't know what happened. So lots of threats inside and outside the organization. General Electric educational facilities, you'll find, were very instrumental in setting up the first computers, the first networks. In the 90s, the government called a conference. Now, one of the things that I'm going to do, and I have it because my area of expertise is programming, web development, database management, and that's what I usually teach. In database management, we talk about security, the security that we have available in those databases themselves, and then we're at a level up in this class. We're securing the whole resources on that system. So a lot of these government organizations and the conferences, I'm going to be investigating myself as we go through. There is my site, and I've got it just everywhere because there's a lot of sites that are out there devoted to security. That's just one of my favorites. Chapter 2 is the type of threats, and that's always a fun chapter. You usually learn things that you didn't know. So this first chapter, let's talk about it in general, and in chapter 2 we'll talk about the types of threats that we see out there today. Be sure to look. What is security now? The state of being secure, free from danger or harm, the actions taken to make someone or something secure. And in our case, it's our data and our networks. The multiple levels, the operations, physical infrastructure, people, the functions of those people, the things that they do, communications and information. We all know, probably, that our former Secretary of State, now I'm not getting political. I'm not going to do that. But Hillary Clinton used email, private email, that was not secure for government functions. And it's an ongoing thing. I just cannot believe somebody that high up in any organization would use unsecure email. It blows my mind. Sorry. So what is security? I've got to pause. I've got a little bit of sinus problem going on, and I'll come right back. Okay. So that really wasn't the look I wanted. Okay. The protection of information, the systems, the hardware, So we're looking at the whole package in this chapter. The security, the data, the network, all of that, the people that are involved. The CIA triangle is the security of the computer, security of the data, security of the network, and you see that it's the people that have access only needs that particular data. You'll see in an organization that the purchasing department doesn't need all of the data that the accounting department needs. So the confidentiality of data. Don't give even people in the organization access to data that they don't need to do their job. In lots of cases, integrity, the availability, making sure that they do have access if they need it. And then we have a policy set down. Our U.S. government didn't have an email policy to make sure that everybody that had access to sensitive data had secure email. I just don't get it. Management information security, and then the safeguards in place for that. Data and services, and there's your triangle again. Confidentiality, integrity, and availability. CIA triangle, nothing to do with our CIA agency. The access, did you know that a company's databases, their data is one of their most important assets? What if Sneed lost your records? What if somebody hacked in to our records? And we've seen that happen in the past where that's actually how Facebook started. Did you know that? Mark Facebook, that's not his last name, but anyway, Mark was a nerd, and he understood programming. He understood how to write social media software. At that time, Harvard was giving that, the computer science professors were giving that as an assignment to develop a social network. He was the first one to really get it and to really understand it, and it's written in object-oriented programming so that the objects, the user, and then all of their objects, work together. He wanted to be able to meet pretty girls. So he hacked into Harvard's database to get the pretty girls' pictures to put on Facebook. That's how it started, I promise, if you'll read a book. So anyway, the assets, our employees, our students are our most important assets. In a company, that asset if it's a bank, it's their customers, right? And the customers' money. So we have access to that information for the people who need it. The asset itself, you hear me call it the resource. People that want to attack it. What controls and safeguards have to be in place? Who's going to exploit it? Who's going to expose it? Who's going to lose it? Honestly, when I worked at Gadsden State, there was a teacher moving. And we have to keep grades for it used to be 7 years. Now they brought it down to 3. So that if anybody, comes back and says, I didn't earn that grade, we can explain it. She was moving. And somehow during the move, a box of her grades got scattered all over the highway. So loss, it happens. The protection and the security that's in place, the risk and being able to assess those risks, who the subjects and the objects are, the threat, the agency, the vulnerability. And you see that I added that those definitions are on page 11. They begin on page 11 and go from there. I am a hacker, and we're going to talk a lot about hackers. We have, I would say, now I haven't counted them up, I bet we have 30 or 40 cop shows on TV. Write them down and see if I'm right. A lot of those have to do with hacking. Abby and McGee on NCIS. They're a hacker. They're a good hacker. And now people that do it for bad uses are called crackers instead of hackers. There's a group called Anonymous. And if you don't know them, I just got to introduce them to you this first chapter. They are what I call the Robin Hood of the computer. Some have been unmasked. Some have went to prison. It's like that Ashley Madison. That Ashley Madison website is for cheaters. People that want to cheat in their marriage online. It's a mental thing, I guess. Some of them probably get for, I don't know. But anyway, the reason Anonymous, someone that belongs to Anonymous, and Anonymous doesn't have a lot of top people and bottom people. They're just all people who want to attack and want to hack. But they shut down Addison or hacked into Ashley Madison because the way Ashley Madison worked is once you joined, it was free to join. But once you joined, you couldn't unjoin. So one of them got mad because he couldn't take his information down. So he hacked into them. So Anonymous, one time they hacked because they were mad that at a company, a publishing company in France, because they were censoring. So Anonymous has just done lots of things. I want you to get familiar with Anonymous. I think it's interesting what they do and how they do it. They're the ones that wear the mask. There they are. They wear those masks. They're a loosely knit group. This one, they're against the practices and the tax status of that group. So they do a lot. They're like a police, an internet police. Sometimes the things they do are illegal, though. Hacking, viruses, malware, it's done with scripts. Okay? If you take an object-oriented programming class and you truly understand that everything related to computers and networks are objects, every object has a name, and all of those objects have tasks that they can do, like a file can open and it can close. That's a task that files objects can do. That's how it's written. Now, I've explained it to you in theory. There's code out there that will show you how it actually works. It's like the little guy who wrote the I Love You virus. He learned how to do it in a programming class in college. He said he did not know that it would do what it do, and he did know that the code was written to do what it does. Dot delete means dot delete. You name that object, dot delete, it's good. So his virus, once it was released, it went to all of these museums in England and deleted all these wonderful images, paintings, music, that millions of dollars worth in damage. He knew he wrote the code to do what it did. I don't think he honestly understood that it would go as fast as it would go when it was released. I believe he thought it wouldn't travel, but it traveled. Okay, so if you want to learn how to do it, you can learn how to do it online. Can I just give you one other thing right at the beginning of the semester, and if you've had me in class before, you have already seen this. Let me get a browser that I hadn't opened a zillion times. Bing is fastly becoming one of my favorite sites. It has a different, really neat picture every day. Yesterday was African elephants. Don't you love it? Anyway, the other thing I wanted to show you is, now, don't go there. It requires software to download. It is, when you start reading about the dark side of the internet, it is a side of the internet that most people never go to. It's called the deep web. It does require software. It is where the bad things are really done. It is estimated that the dark side is 500 times bigger than the internet we all know and love. Okay? So if you're a student in this class, I want you to know what it is. I am not encouraging you to go there in any way. I'm encouraging you to learn about it to safeguard you and your companies from anything that may happen there. Enough said. Okay, so this is the database that I talk so much about. And if you're in my CIS180 class, one of the first things I ask you to do is to make a list of all the databases that you are in, okay? And it'll surprise you, I think. The first time I ever taught that class, one student had a list of over 200, and that's probably pretty close. We're in some we don't even know we're in, right? You're in the database for SNEED, of course. You're in the database for every bill you have. You're in the database for your banks. You're in the database for every form you have ever filled out on the internet. So the security of that data that resides on networks is what this class is all about. So what are the attacks? Critical characteristics of information that is available. It is available when the user needs it. That's accurate, and that's the accuracy, the availability, the authenticness. All of that is part of database class 2. Available, accurate, authentic. It's confident. It has integrity. It has a utility, and it has possession. So let's take a look how they plot it out for us. Now, this is a security model, and this is what you will dissect if you're going to get certified in cybersecurity. That certification is the first assignment in this class, is for you to look at those certifications. And if you look at the book, one of the guy who reviews it says that there's more than one, and he gives you his opinion on which is the best. And you'll see that that National Cybersecurity Institute is one of the things one of those resources that we'll want to stay in touch with as we go through this class. So we need a policy in our company, the storage, processing, and transmission, and then that it's good. Okay. Let me see. Let me go back right here. These and the discussion of these begin on page 14. And sometimes in the PowerPoints, as I went through reviewing before I actually started doing, as I put the page number, and I wish I had it on this. This begins on page 14 in your book. There's also a thing, as we're looking through those pages, on page 16 about unintentional disclosures. A lot of things happen that is human error in companies, and they can be really expensive. Human error is hard because the person that did that usually does not mean to, or I've actually done it, and I tell you what, it's something hard to get over. So take a look as you go through. Read on page 16, the unintentional disclosures. Okay, the components of an information system: software, hardware, data, people, procedures, and networks. Including in that networks, of course, is the computers they use to get into that network and all those kinds of things. The hardware, that's the computers and all that. The software that runs on that hardware. The software that allows you to keep this data, and then the people who run all this stuff. What the companies really have to have is the procedures. Do like Chapter 6 and risk assessments, and then put policies and procedures in place for every member of that organization, no matter who they are. You can read it. I'm going to just look at a brief go-through, but you can read it as you go through. there's a balance, and that's what we're talking about. I totally believe it's a goal. It's a process. It is impossible, I believe, to make sure that information is secure in our day and time. We have all kinds of tools. It requires a rigorous implementation and maintenance on the part of IT people to protect against the threats that we have there. User IDs, passwords, security questions, type in the word, and do you see, type in the word seen. You know, I thought I had meant screen when I added that remark. System administrators, they have to be trained and have technical expertise in this class, and you'll see in chapters 4, 5, 6, 7, and 8 that if you know networking, you're better off. The TCP IP and the different in that TCP IP models, the different securities at the different levels of that model. I'm going to have to pause just one more time. Maybe it'll be one more time. So the approaches for that security, and honestly, this area, IT professionals have really gained in careers and salaries because it's an important job that they do. The upper management sets the policies and procedures based on information from the IT department, the people who assess the risk, the people who decide what software and computers and networks are going to be put into place. So anyway, all of us working together. Now, I look CEO all the way down, security manager, systems manager, network manager, depending on the company, how many people is that? Okay, our life cycle. The systems development life cycle, and then I tell you to go to slide, do you see my note here? I got to look at slide 38. I should have put me a link to go there. Begins with the information security policy. No, I have changed my slides since that, and I'm sorry. I will go back and upload this again and put a link to the slide. But anyway, there's two. The SEC, SDLC, so that, and we'll just go straight. Then the systems development, just what has to go into place, the methodology, how you're going to solve that problem of risk, and assessing what you need, define the goals, the 6 general phases: investigation, the analysis, the design, the logical and physical, put it into place, and then maintain it and change it. And actually, this is really similar to, say you're creating a program. You investigate the problem, you know, what it needs to solve. You think about it logically and design it with the end in mind. Then you do the physical design. You code it, you run it and make sure it works, then you maintain it. So the life cycle development, good test questions as you go along. The objectives, the constraints, the scope, all of that, the time frame, cost-benefit analysis. At the end of all of it, money is involved. It really is, software and all that. The analysis, the organization, the systems that they're using, including the people, the logical design, like I just said, the software that you're going to do it with, all of that stuff, the physical design. I have a company here in town right now that wants an intern that's able to draw a schematic. She wants her network drawn out on paper so that it's easy for them to look at that schematic and see the computers, whatever resources are on that network. So the logical and the physical design is important. It's important that top IT people don't just keep it in their head, that they share that information. And I know putting it on paper gives a way for it to be lost or stolen, but it does need to be on paper, in my opinion. Everything being online, if it's off, you don't have access to it. I'm sorry. Then the implementation software is actually created, ordered, put into place. The maintenance is the longest and the most important. Changing from one system to the other it's hard. You know, you've got to keep the ongoing system going for a while. You have the cost of the ongoing system. You're putting in a new system. This is on page 29, as you can see my note. I do try to go to it and go through it before I actually sit down and try to record the video. But this has the phase, page 29, and I thought, no, they don't actually put it in the book, I guess, in the PowerPoint, and it should be. Okay, the phases and then the steps for each phase, and then the steps that are unique for security systems. So take a look at page 29. It's important as you go through. Physical. Oh, sorry. It's almost like it was Monday, which it will be in a few days. Okay, the software assurance, know the dangers, be ethical. Software is a ongoing learning, ongoing evolving technology too. There's all kinds of software that is going to keep going. So when I teach programming, especially object-oriented programming, I try to note these things to students. But in programming like C++, where we're just trying to cover the basics of programming, I show you how to write out to external files and how to read from those files. But I don't go into the security at all. At that stage, I just don't want to put that seed in your mind. But Microsoft, for example, is better now with their operating systems. They used to release operating systems with none of the software ports protected. There was no security in that operating system. So you see that secure software starts all of these things. The security of software has just got to be there. Windows 10 already has sent me a notice that there's some insecurities when they're downloading updates for that operating system. So everything is software, right, that runs on hardware. So the security's got to be there. What I did here, and I know that if you're a networking guy, you know this, you cover it, but for those of you that are new, there are approximately 65,500 software ports. Now, that is not talking about that physical port in the back of a computer where you plug things into. That's not what it's talking about. It's talking about the ports. Now, let me just bring it up. Did I copy that? I did. Okay. So these are the ways that emails get into you, that when you get an attachment on email, got a zillion things going to my brain, it looks like. Then they're numbered, the ports are. Let me get down to some that you will recognize. This is the way that the computer's operating system knows where to go to open that document. So they're called software ports. They're dedicated, and some of them are not dedicated. There's the Telnet software port. There's VMware software port. There is a software port for Word. There's a software port for Excel. There's Boomerang. There's a software port for any document that you're going to try to send over a network. So there's the thing about it is I've got to look back and see some of them are color coded now on Wiki to see why. Some of them are for particular vendors. See, there's an IBM software port, Windows PowerShell software port. So they go, and some of them are still not put out. Do you see that it goes to 49, but then it goes up to 65,000? So understanding, and that's what they were talking about. Establishing all of the connectivity on the internet. You know, the internet itself is just a network of networks. If you have URLs that end in S, it's supposed to be a secure site. If it's www, it's the World Wide Web. Anybody on the internet can read it. So if it's secure, it has an S, and I don't know why Wikipedia would have a secure site since I could do it, but if you look at the things that you have to put in user ID and passwords for, like Blackboard, it's a secure site. It doesn't have a www. I may have actually put this slide, and I think I did, in myself. Excuse me just for, again,